All right, so number 1, consider the quadratic qx squared minus 4px plus pq squared is equal to 0, where p and q are both positive integers. Express the sum and products of the root of the equation in terms of p and q. So first, I want to write down what a, b, and c is. So a is equal to q, b is equal to minus 4p, and c is equal to pq squared. So the sum of the roots is going to be alpha plus beta. No, they didn't say in terms. So here what I'm going to do. I'm going to say let the roots of the quadratic be alpha and beta. I just try nothing. I don't know if it's an alpha beta question, but it's okay. The sum of the roots is going to be alpha plus beta, which is going to be minus b over a, which is minus 4p over q, which is 4p over q. And the product of the roots, alpha beta, is equal to c over a, which is p q squared over q, which is just pq. Determine the value of q for q such that the sum of the roots is equal to the product of the roots. So I'm going to let alpha plus beta be equal to alpha beta. I'll get 4p over q is equal to pq. Cross multiply. 4p is equal to pq squared. Divide both sides by p. 4 is equal to q squared. And q is going to be plus or minus 2. But q is a positive integer. So q is an element of the positive integers. So therefore, q is equal to plus 2. If the sum of the roots of the equation is 20, so alpha plus beta, which is equal to 4p over q, 4p over q is equal to 20. Use your answer from A part 2 to determine the value for p. So if q is plus 2, alpha plus beta is actually 4p over 2, which is equal to 2p. 2p is equal to 20. P is equal to 10. Hence, express the given quadratic in terms of its numerical coefficients. So I'll write it down here. Qx squared. I just put this down here and I'll go copy it down, right? Q is equal to 2. P is equal to 10. So Qx squared minus 4p x plus pq squared is equal to 0. 2x squared minus 4 into 10 x plus 10 into 2 squared is equal to 0. Simplify down. 2x squared minus 40x plus 2 to the 4 plus 40 is equal to 0. Did they want it in its... I mean, if you want, it is an equation. So because it's an equation, I can now fix it up a little bit. So this is part 4. I can fix it up and say x squared minus 20x plus 20 is equal to 0. All right, part B. Show that the series is geometric. If the series is geometric, then I could calculate the common ratio in both cases and get the same thing. So if I let A be equal to, actually let T1 be equal to 25. A series is given by 25 minus 5 plus 1 minus 1/5 plus. So what I'm going to do, I'm just going to insert some commas here, right? +1 minus, good. Let T1 be 25. Let T2 be -5. Let T3 be 1. Let T4 be -1/5. And let T5 be 1 over 25. Now I go overdo it. R is equal to T5 over T4, T4 over T3, T3 over T2, T2 over T1. 1 over 25 divided by 1/5. -1/5, sorry. -1/5 over 1. 1 over -5 minus 5 over 25. So it's gauging up to give me a -1/5 for all the answers. R is equal to -1/5 -1/5. Therefore, the series is definitely geometric. Yeah? Calculate the sum to infinity of the series, giving an answer to two decimal places. The sum to infinity is a over 1 minus r. In this case, r is -1/5, which is equal to, I will just let a be equal to t1, so I change in my let above a little bit. So I'll get 25 over 1 minus 1/5, sorry, which is equal to, jump on my calculator, I'll pull up my calculator here. 1 plus 1/5, 25 divided by that. I get 20 and 5/6, and I want it to two decimal places. 20.83 to two decimal places. Alright, so we go to that so far. Alright. A recent university graduate was offered a starting salary of $720,000 for the first year, with increases of $5,000 at the start of every year thereafter. Determine the number of years it would take for her annual salary to be 20% greater than her salary for the first year. So if I want to know, well, first things first, A is $720,000. And D going to be 5,000. Now I want to know what this end figure is going to look like. So 20% of her salary. So 20, let me put statements now. Determine the number it would take for annual salary. So 20% by $720,000 is equal to 1212. Oh, let me just calculate 120% to get the full amount, right? Because when we calculate the 20%, we got to go and add it to the original salary. So 120 by 720 is 86,700. So $864,000. So we get 864,000. So I want to know how much years it will take to get to here. So there's an easy thing. I could say let Tn, let T sub n be equal to 86400, and know that our Tn is equal to A plus n minus 1 by D. I have A and D. So 86,400 is equal to 720,000 plus n minus 1 by 5,000. I'll take away 720,000 first. I get 144,000. N minus 1 by 5,000. I'll divide both sides by 5,000. I get 28.8, or, oh shucks, multiply by 5,000. I just fixing it on my calculator. 144 over 5, 28.8, yes. N minus 1. Add 1, I get 29.8 is equal to n. But I cannot have n being a decimal like this because I'm looking for some term. So technically, it takes 29.8, what is this? Years? Yeah, it will take 29 point years, boy? All right, it will take 29.8 years. Oh, they wanted it to the nearest whole number, right? It will take 29.8 years for his salary or whoever's salary to reach the $864,000. But they did say to the nearest whole number, so n is equal to 30 to the nearest whole number. Right, and that's it for number 1. Number 2, when the polynomial expression that is divided by x plus 1 and x minus 2, the same remainder of 64 is obtained. So my first option, I will let f of x be the polynomial, 2x cubed minus 3x squared minus cx plus d, f of x divided by x plus 1 is equal to f of minus 1, which is equal to 2 into minus 1 cubed minus 3 into minus 1 squared minus c into minus 1 plus d. Minus 1 cubed is minus 1. So I get minus 2 minus 3 plus c plus d. And this is equal to 64. Now, I would have utilized the remainder and factor theorem here. So, as a result, I'm going to quote the remainder and factor theorem. If any polynomial f of x is divided by x minus a, the remainder is f of a. If f of a is equal to 0, then x minus a is a factor of f of x. So I use the remainder part here. I didn't use the factor part, but I still had a quote remainder and factor theorem. Next, f of x divided by x minus 2 is equal to f of 2, which is equal to 2 into 2 cubed minus 3 into 2 squared minus c into 2 plus d. Same remainder, I'm going to get 64 is equal to 2 to the 4 to the 8 to the 16. Oh, I'm supposed to simplify this a little bit. I'll go simplify just now. 16 take away 2 to the 4, 4 to the 12, minus 2c plus d. Let me fix up this one here. I'll get 64, take away 16, plus 12. 64, take away 16, plus 12. I get 60 on this side is equal to minus 2c plus d. Let me move the minus 2c now. 60 plus 2c is equal to d. I'll fix now the top one, and I'll go say 64 plus 5. 64 plus 2 plus 3 is 69. So I'll get 69 is equal to c plus d. I will let this be 1. However you want to line them up, you could line them up, rearrange them, and then let them be 1 and 2. I'll substitute 2 into 1. I'll get 69 is equal to c plus d, which is 60 plus 2c Rearrange 69, take away 60 is 9 is equal to 3c, and c is equal to 3. Then, right here, substitute c is equal to 3 into equation 2, and I'll get d is equal to 60 minus 2 into c, which is 3, and d is equal to 60 take away 6 is 54. Plus, what are we doing by plus 66? Yeah, we got to go. All right, show that the expression that is the same as root 5 on 3. Now, I want to give you a little bit of advice here, right? Now, I will be doing my working on the right-hand side of the paper, but all you're going on how to be writing on the paper. So there's a little trick you all can do. Or you could utilize the whole space of the paper. Actually, start working over here and partition your paper in such a way that you do working coming on the road, draw arrow, you do working coming on the road, draw arrow, you do working coming on the road, draw arrow, and you do working coming on the road, and well, you had to draw an arrow in the end. I'm going to do it for part B. All right? I'm going to utilize the space I have on the paper for part B. So, root 25 divided by root 45 is equal to 5 divided by, if I want, I could rationalize, right? There's 5 over root 5 by root 9, which is 5 over 3 root 5. What I'm going to do, I'm going to rationalize and multiply by the conjugate of the denominator. Now, in this case, you don't have to multiply by the conjugate of the denominator. When we're rationalizing, we just want to multiply by 1 in order to get rid of the square root on the denominator. And one thing I can do to do that is I'll have 5 divided by 3 root 5 multiplied by root 5 over root 5. That is one thing I can do. The top are going to get 5 root 5. The below are going to get 3 root 5 by root 5 is 3 multiplied by 5. The 5 cancel with the 5, and I get root 5 over 3. And I'm done. So I didn't pick up much space here. If I had more, I would have just go up and do the more. All right, so you all can adapt this approach when you are writing all the exams for CXC this year. All right, express this in the form a into x plus h squared plus k. I'm going to do the same thing where I utilizing the space on the paper, right? So I'll have 6x squared plus 12x minus 18. Draw my partition, and I'll do my working coming down. I'll get 6 into x squared plus 2x, close brackets, I'm rubbing off partition, minus 18. I'll get, what I'm going to do, it have plenty ways to do it. I can do it in one line if you'll understand what completing the square actually does, where I have to add half the coefficient of x, which is half of 2, to be squared, take away 18, then I had to take away 6 into 1 squared. Now the middle, the brackets is a perfect square, that is x plus 1 squared, minus 18 minus 6 is minus 24, is of the form a into x plus h squared plus k, where a is 6, h is 1, and k is minus 24. Use the expression in C part 1 to determine the roots of g of x. So they want us to use this completed square version to calculate the roots of the equation. No scene. So I'm going to get a, 6 let 6 into x plus 1 squared minus 24 be equal to 0. Move the 24. 6 into x plus 1 squared is equal to 24. Divide both sides by 6. X plus 1 squared is equal to 24 over 6 is 4. Square root both sides. X plus 1 is plus or minus 2. X is equal to plus or minus 2, take away 1. I get my two solutions. Plus 2 take away 1, which is 1. Or x is minus 2 take away 1, which is minus 3. Right, this is our maths question. Hence, sketch the graph of g of x in the following grid. So, I will do some working. I have space underneath to do some working, right? So, I'll go in and say that this here is a positive x squared. So, a is greater than 0. Therefore, we have a smiley face because we're happy. Next, the minimum point is going to be minus hk, which is equal to, I believe h was 1, so minus 1. K is minus 24. Minus 1 minus 24. This is sketch, right? So we don't have to be as accurate to just say sketch. The roots, the x-intercepts are 1 and minus 3. X-intercepts are x is 1 and x is minus 3. And finally, the y-intercept is going to be c, which is negative 18. The y-intercept is equal to minus 18. So let me see how best we can draw this, right? I'll draw it in a color such that I can see the color in the diagram. This is my curve. My x-intercepts are 1 and minus 3. So I draw my x-axis here. Now this is sketch, right? This is sketch. So I don't have to be so 100% accurate. I have to put in the numbers though. Over here is my minus 3. Over here is my 1. The y-intercept is minus 18. And this point here is going to be minus 1, comma, minus 24. So I know my x-axis, my y-axis, sorry, going to drop somewhere here in order to facilitate the minus 1. I'm going to straighten this out a little bit. Yeah, in order to facilitate the minus 1. Now, how this was scanned, the graph bend, right? The graph paper itself on the paper bend, how it was scanned. This minus 1 minus 24. So this here going to be minus 1. This here is minus 24. And the x-intercept is minus 18. And this is the graph g of x. And that looking like it for number, yeah, that looks like it for number 2. Number 3. The circle, the equation of a circle is so by so. Determine the coordinates of its center and the length of the radius of the circle. So I'm gonna do my working on the side here because I mean I could do the working a little bigger so everybody could see. So x squared, I go put the x's next together, plus 4x plus y squared minus 8y plus 10 is equal to 0. I'm going to bring it into the form x squared minus 2 multiplied by something x plus y squared minus 2 multiplied by something y plus 10 is equal to 0. What must go here in order to get back plus 4 and minus 2 must go here? What must go here in order to get back a minus 8? I already have minus 2, so a 4 must go here. And I'm done. Is of the form x squared minus 2fx plus y squared minus 2gy plus c is equal to 0, where fg, well, the center, is equal to fg, which is minus 2, 4, and the radius is equal to the square root of f squared plus g squared minus c, which is equal to the square root of f squared plus g squared minus 10. 2 twos are 4 and 16. 16 and 4 is 20. 20 take away 10 is 10. So I get root 10 to be the radius. Square root of 10 units. Right, not so bad for that one. Next, determine the equation of the tangent to the circle at the point P minus 5, 5. All right, so a quick sketch could help us out here to see what's going on. So I'm a circle, I'm a center. Let me just pretend this is the point P. I know the center is minus 2, 4. I just pretending, it don't have to be accurate, right? This here is P, this here is the tangent at P. So I know that our radius and tangent is 90 degrees. I have to calculate the gradient of the radius, flip it to get the gradient of the tangent, and then use the point P to calculate my equation. So, part 2, let the tangent at P be, I like to use L1, the gradient of the radius. If you wanted to name the center O and then say the gradient of OP, you could go ahead and do so. The gradient of the radius is y2 minus y1 over x2 minus x1, which is equal to, I will label the center as x1, y1, and p as x2, y2. Now remember, everything on the right and on the paper, so the person who marking it, seeing all the x1, y1, and x2, y2. y2 minus y1 over x2 minus x1. 5 minus 4 is 1 over minus 2 plus 5 is going to give me 3. So my gradient of my radius is going to be a third. The gradient of L1 is going to be negative 3. And we have two reasons why. The first reason is a radius meets a tangent at 90 degrees at the point of contact. Also, the product of gradient of perpendicular lines is equal to minus 1. Now I can get the equation of L1, and I had to use the point P, which is minus 5, 5. This could be my x1, y1 for my equation. Y minus y1 is m into x minus x1. Y minus 5 is minus 3 into x minus minus 5. So y is equal to minus 3x. 3 minuses, that will be a minus 15 plus 5. Y is equal to minus 3x minus 10 is of the form y is equal to mx plus c, where m is my gradient, is minus 3, and c is my y-intercept, which is equal to minus 10. X2 take away x1. Okay, I make one slight mistake here, so let me fix it one time and I'll see in a day. In this here, I put x2 to be minus 2. x2 minus x1 is going to be minus 5 minus minus 2, which will give me minus a third. So the gradient of L1 will be positive 3. And that just changing the equation by 1. I'll get 3 into that. which will be 3x, and I will end up having plus 15 and plus 20. All right, cool. All right, sorry about that little mistake there, guys. Now I know this writing a little small, but I'll read out the question. The vectors OX and OY are such that OX, and I put in my arrow, is 4I plus G, and OY is I minus 4G. Show that the vectors OX and OY are perpendicular. All right, so I'm gonna make life a little easy for myself. I'll let little x be this and little y be this, just to make life a little easier for myself, right? So if the vectors are perpendicular, their dot product is equal to 0. So I have x, I have y. I'm just going to change these things into column vector form. So I could say x is equal to 4, 1, and y is equal to 1 minus 4. So if x dot y is equal to 0, x and y are perpendicular. So x dot y is equal to 4, 1 dotted with 1 minus 4, which is 4 by 1 plus 1 by minus 4, which is going to be 0. Therefore, x is perpendicular to y. The diagram below, not drawn to scale, shows a chord AB which subtends an angle of 5 radians at the center of a circle radius 10 centimeters, given that the area of triangle AOB is a half r squared sine theta. Calculate the area of the shaded region. So I had to calculate the area of the sector. So the area of the sector is equal to 1 half r squared theta, which is 1 half 10 squared 0.5, which is 10 squared is 100, and half of 100 is 50, and then half of 50 is 25. So I'll get 25 centimeters squared. The area of the triangle, they give me the formula, is a half r squared sine theta, which is 1 half 10 squared sine of 0.5. Now we have to put the calculator in radians in order to do this. So radians. A half, 100 sine 0.5, 23.97 to 2 decimal places, centimeters squared to 2 decimal places. And just like I said before, you can organize your work like this: partition with an arrow, area of shaded region going to be 25 centimeters squared, take away 23.97 centimeters squared. That looking like a 1.03, which I can see. Let's take away 25, 1.03. We're good to go. 1.03 centimeters squared. All right, so show that cos 2 theta is 2 cos squared theta minus 1. All right, that's easy. So it have a number of ways in which we can do this, right? There's identity that we proved before. So I gotta recall my compound angle formula. Cosine of A plus B is equal to cos A cos B minus sine A, sine B. Let A be theta. Let A be equal to B be equal to theta. So I'm going to get cosine of theta plus theta is cos theta minus sine theta. I'll get cos 2 theta is cos square theta minus sine square theta. I'll recall my Pythagorean identity. Sine square theta plus cos square theta is 1. So sine square theta is 1 minus cos square theta. So cos 2 theta is cos square theta. Take away 1 minus cos square theta. Cos 2 theta is cos square theta minus 1 plus cos square theta. And cos 2 theta is 2 cos square theta minus 1 QED. Now, I don't know if the question wants us to use the compound angle formula or not, because an identity that we're supposed to know is cos 2 theta is cos square theta minus sine square theta, but just dot with t's, cross with i's, we should be good to go. Hence, solve the equation that between 0 and 2 pi. So, if I have cos 2 theta plus cos theta plus 1 is equal to 0, for 0 is less than theta is less than 2 pi, I go have 2 cos square theta minus 1 plus cos theta plus 1 is equal to 0. It's an easy one. 2 cos square theta plus cos theta is equal to 0. I'll have cos theta into 2 cos theta plus 1 is equal to 0. I'll have cos theta is equal to 0. I'll dive into or I'll put the or with a big space, or I have cos theta is minus a half. I'll dive into my quadrants. Cos theta is 0. Well, solutions will lie in all 4 quadrants. So my principal value is going to be cos inverse of 0, which is equal to 0. Theta is the principal value, which is equal to, oh, I'm going to double check that, cos inverse of 0. Radians, good. Cos inverse of 0 is pi 0. Oh, yes, pi on 2. Pi on 2. My principal value, sorry, theta is, did I put cos inverse? Yeah, right, I pi on 2. Theta, yeah, that's correct. Theta is equal to pi minus the principal value, which is pi on 2, which is pi on 2. Theta is pi plus the principal value, which is pi on 2, which is 3 pi on 2. And theta is 2 pi minus pi on 2, which is 3 pi on 2. I have to dive in the second revolution. Theta is equal to 2 pi plus pi on 2, and this is out of the given domain. Again, I'll dive into my quadrants for the second one. In this case, it's a little bit easier because my solutions are going to lie in quadrants 2 and 3. Principal value is going to be cos inverse of a half. And come here, make life easy now. Change it in degrees. Cos inverse of a half is 60 degrees. 60 degrees is pi on 3. So, which is equal to pi on 3. Theta is pi minus pi on 3, which is 2 pi on 3. And theta is pi plus pi on 3, which is equal to 4 pi on 3. I had to go in the next revolution. In the second rev, theta is 2 pi plus 2 pi on 3, and it's out of domain. 3 marks is plenty working, boy. My solution theta is equal to pi on 2, 3 pi on 2, 2 pi on 3, and 4 pi on 3. What cool it. Oh god. Alright, that's it for number 3. Number 4. Given that f of x is x into 5 minus x all squared, so f of x is equal to x into 5 minus x all squared. We want to get the second derivative because I got to differentiate this once, differentiate twice. Because I had to differentiate it twice, I'm going to expand this out. X into 25 minus 10x plus x squared, which is 25x minus 10x squared plus x cubed. That is f of x. Now it's easy. F dash x, or the first derivative, is 25. Take away 20x plus 3x squared. And f double dash x is going to be minus 20 plus 6x. Good to go. Differentiate each of the following expressions with respect to x, simplifying your answer where possible. So what I'm going to do for part 1, I'm going to let y be equal to 2 sine 3x plus cos x dy dx. When I differentiate sine, it turns to cosine, but I also have to multiply by the differential of the angle. When I differentiate the angle, I get 3. And when I multiply this by 3, I'm going to get 6, and the sine changes to cosine. When I differentiate cosine, I'm going to get minus sine. Part 2, I'll also let y be equal to 1 plus 2x all cubed into x plus 2. I'd have a number of ways we could go ahead and differentiate this. The easiest way is using the product rule. We say is of the form uv, where u is 1 plus 2x all cubed. And when we have a chain rule inside of a product rule, I can use the shortcut. This is 3 multiplied by 2 multiplied by 1 plus 2x to the power 2, which is 6 into 1 plus 2x all squared. And v is equal to x plus 2. And the v dx is equal to 1. Just to save myself some space and some hassle down the road, I'm going to say dy dx is equal to this is equal to v times du dx plus u times dv dx. This is my product rule. This is equal to v times du dx, which is 6 into 1 plus 2x all squared, plus u, which is 1 plus 2x all cubed, by the v dx, which is 1. I can factorize this by factorizing 1 plus 2x all squared into 6 into x plus 2 plus 1 plus 2x. You don't have to factorize, fellas. 1 plus 2x all squared, unless the question says so. And the question did say so. Simplifying your answer where possible. You could simplify this into 6x plus 12 plus 1 plus 2x. I'm going to get 1 plus 2x all squared into 8x plus 13. And this is my dy dx. All right, next. Determine the stationary points on the curve y is equal to x cubed minus 4x squared plus 4x. So y is equal to x cubed minus 4x squared plus 4x. Differentiate dy dx 3x squared minus 8x plus 4. We say at a stationary point dy dx is equal to 0. So we will let 3x squared minus 8x plus 4 is equal to 0. That is 12. Damn. Let's see if this could be solved now. Calculator. Check the calculator. 3 minus 8 and 4. Yeah, it could be factorized. So let me factorize it. 4 3s are 12. Oh, minus 6 and minus 2. 3x squared minus 6x minus 2x plus 4 is equal to 0. 3x into x minus 2 minus 2 into x minus 2 is equal to 0. I got x minus 2 into 3x minus 2 is equal to 0. I got x is 2 and x is 2/3. Then when the coordinates are the stationary point. So we say when x is equal to 2, y is equal to, and you can jump on a calculator and do this, right? Nothing is wrong with going on a calculator to do this piece here. So jump on a calculator. When x is 2, I'm going to get 2 cubed minus 4 into 2 squared plus 4 into 2. I'll get y 0. And when x is 2/3, y is equal to, so all I do now, I put in my bracket, 2 over 3, close bracket squared cubed, 2 over 3, 2 over 3. I get 32 on 27. So therefore, stationary points occur at 2, 0 and 2/3, comma 32 over 27. All right, Monda. Providing details determine the nature of the stationary points in C, part 1. All right, so it have a number of ways we can do this. When I have a positive x cubed, that curve looks like this. Negative x cubed looks like this. You could say that, or we can just dive into the second derivative. Granted that there's just 2 marks. I like to show calculations, so I will go and use the second derivative, right? I'll go and say that d2y over dx squared is equal to 6x minus 8. At x is equal to 2, d2y over dx squared, I'll get in 6 2s are 12. 12 minus 8 is 4. I mental it. It's greater than 0. Therefore, at x is equal to 2, there is a minimum point. At x is equal to 2/3, d2y dx squared is less than 0. Therefore, at x is equal to 2/3, there is a maximum point. And this follows the concept I now showed you guys. Positive x cubed is like this. Which one of these turning points comes first? Well, this x value comes first. So this is going to be my 2/3, comma 32 over 7. This is going to be my 2, comma 0. We could say the first one is a maximum and the second one is a minimum. Right? In this case, this is the first one when x is 2/3. And that's it for number 4. Number 5, determine the integral of 4 cos theta minus 6 sin theta d theta. So the integral 4 cos theta minus 6 sin theta d theta, I always like to put this on the side. If y is equal to cos x, dy dx is equal to minus sin x. So if I integrate sine, I'm getting back negative cosine. And if I integrate cosine, I get back positive sine. So when I integrate cosine, I get positive sine. So I'm going to get 4 sine theta. And the angle is just a singular angle, so I safe. If the angle was a multiple angle, like a 3 theta or 4 theta, I'll have to divide by the differential of that. So let me just say, for instance, the angle was 2 theta. I'll have to divide this by 2. Take away 6. Now the sign changes to negative cosine. I'll get minus 6 cosine theta. I don't want to put plus c because c is part of cosine, so I'll go put plus k, where k is a constant. So I'm going to get 4 sine theta plus 6 cos theta plus k. Now we have a definite integral to work with. We need to evaluate the integral between 2 and 1 of 3 minus x squared dx. Again, I go expand this. The integral between 2 and 1 of 9 minus 6x plus x squared dx. This is 9x take away 6x squared over 2 plus x cubed over 3 between 2 and 1. So I'll simplify while I plug in my limits. I'm going to get 9 into 2, take away 2 into 6 is 3, 3 into 2 squared plus 2 cubed over 3, take away 9 into 1, take away 3 into 1 squared plus 1 cubed over 3. My advice is to go ahead and work out the first bracket first. So the first bracket going to be 9 into 2, take away 3 into 2 squared plus 8 over 3. I get 8 and 2/3 for my first brackets. Take away. Now this one will be a little bit easier. There's 9, take away 3 plus a third, which is 6 and a third. I like to double check, 8 and 2/3, take away 6 and a third is, I put 6 and a half. 6 and a third is 2 and a third. Now, up to now, the question never indicated that our part B was our area, so I'm leaving it like 2 and a third because it just say evaluate the integral. If they say calculate the area, given that this, then I'll go put square units. Determine the area of the region bounded by the curve y, the x-axis, the y-axis, and the line x is 2. So I already have my 4 boundaries. I am comfortable to say let A be equal to the integral between the lines 2 and 0, because that's my y-axis, of 5 plus 5x minus x squared dx. The same thing like above, but now I just had to put square units. So A is equal to 5x plus 5x squared over 2 minus x cubed over 3 evaluated between 2 and 0. A is equal to 5 into 2 plus 5 into 2 squared over 2. Take away 2 cubed over 3. Now, although we know that how the next substitution is going to result in 0, you have to show the substitution, please. Get in the habit of doing it. 5 into 0 plus 5 into 0 squared over 2 minus 0 cubed over 3. Diving into the calculator, A is equal to, you can mental piece, 5 2s are 10 plus 2 2s are 4, 5 4s are 20, 20 divided by 2 is 10, take away 8 on 3, 17 and a third. A is 17 and a third square units. A particle moves in a straight line so that t seconds after passing through a fixed point O, its acceleration a is given by 3t minus 1 meters per second squared. When t is 2, the particle has a velocity of 4 and a displacement of 6 meters from 0. Determine the velocity when t is equal to 4. So we'll remember our SVA. To get velocity, we have to integrate acceleration. So v is equal to the integral of a with respect to t. V is equal to the integral of 3t minus 1 with respect to t. V is equal to 3t squared over 2 minus t plus c, where c is a constant. Now they gave us a condition satisfying v and t. We know that how when t is equal to 2, v is equal to 4. So we go let 4 be equal to 3 into 2 squared over 2 minus 2 plus c. We could go ahead and work this out on the calculator. This is 4 plus 2 is 6. If I move the 2 across, I get plus. So 4 plus 2 is 6. And this here, 3 into 2 squared. 2 2s are 4, 4 3s are 12. 12 divided by 2 is 6. So I'm going to get 6. Well, 6 minus 2 is 4. And I get c is 0. Oh, Jesus. A small thing. So I get c is equal to 0. So therefore, v is equal to 3t squared over 2 minus t. We are done yet. They want us to calculate the velocity. Forget the line bend, that's small thing, right? The velocity when t is 4. When t is equal to 4, v is equal to 3 into 4 squared over 2 minus 4. Jump on the calculator again. 16 by 3, 48 divided by 2, 24 minus 4 is 20. So v is equal to 20 meters per second. So that second piece of information, the displacement of 6, it ain't make any difference. That had no part to play in this question whatsoever. Right, and that's it for number 5. All right, number 6. At a school canteen, 80% of the students, S, purchase chips, C, and 55 purchase chicken, K. Oh, good Lord. All right, so students is S. 80% of the students purchase chips and chicken. All right. Of the students who purchase chicken, 11% do not purchase chips. So copy the following Venn diagram, right? So at a school canteen, 80% are the students. So let me put this into perspective, right? If 80%, did they give us a total number of students? They didn't. 80% of the students will represent 80 over 100. So 80% going to be 8 out of 10. 80 over 100, 8 out of 10, 4 out of 5. 55%, this is C, right? So this is S, sorry. I am going to to see what is chicken and chips something. I just going to put S, C, and K. Oh, there's C. At the school canteen, 80% of the students purchase chips, 55% purchase chicken. So 55% gonna be 55 over 100, which gonna be 11 out of 20. This key. All right, so this changes the dynamic of the question a bit, because initially it could be confusing when you read the question to see 80% of the students S, to think that the entire Venn diagram will be 80%, but the Venn diagram will be 100%. So try not to make that mistake, right? So if C is 4/5 and K is 11 over 20. Let me change this to over 20 as well now. This is 16 over 20. So we have 11 over 20, 16 over 20. C for chicken. Of the students who purchase chicken, 11% do not purchase chips. So of the students who purchase the chicken, 11% of them do purchase chips. So that means 44% of the students who do purchase chicken does purchase the chips. So if I work strictly in percentages, right? If 55% purchasing chicken, this whole thing is 55. And out of the 55, yeah, out of the, this students who purchase the chicken, out of the 55%, 11% do not purchase chips. So 11% do purchase chips. That means 44% purchase chips, which means 44 go how to go here, and 11 go how to go here, because this 11% does not purchase the chips. Cool? So this 11% purchases chicken only. Chicken, sorry, C, which represents chips, is 80%. I already have 44% inside of here, so I remain with 36% inside of here. All right? Now all these percentages, right? Granted that the whole thing's supposed to be 100%. 36 plus 44 plus 11 is 91. So I'm going to end up with a 9% on the outside. So if you want, you could have put the percentages in the Venn diagram. Or if you wanted, we could have put fractions in the Venn diagram. If we wanted, it will have the same effect. Because 36% could be expressed as a fraction, 44% as a fraction, 11% as a fraction. So what I'm going to do, I'm going to put the percentages sign inside of here. To show that our percentages we're working with are not 11 children purchase K alone. Determine the probability that a student chosen at random purchases only chicken or only chips. So if I let X be the probability, not the probability, the event, a student purchases only chicken I could put or only chips. We could get this from the Venn diagram. Or only chips. The probability of X is going to be equal to only chicken or only chips 36 plus 11. That is what? 47? That would be 47% or 47 out of 100 because we're looking in percentages here. All right, so this question was a bit confusing at first, but hopefully the explanations cleared up everything for you guys. The probabilities of the occurrences of two events A and B are given as this, that, and that. A intersect B. So De Morgan's law, the probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. A union B is 7/10. Probability of A is a quarter. Probability of B is 3/5 minus the probability of A intersect B. So just rearrange, put the A intersect B in front. Shucks, probability of A intersect B is 1/4 plus 3/5 minus 7/10. A quarter plus 3/5. Sorry about that. I put divide 7/10. Sorry about that, guys. My apologies. I made the wrong thing, yes? Alright, that's okay. My apologies on the sneezing, everybody. I get 3/20. The probability of A given at B. Probability of A intersect B over probability of B. A intersect B is 3/20. B is 3/5. 3/20 multiplied by 5/3. The 3's cancel. So 3/20. 3/20 divided by 3/5. I'll get a quarter. I'll check something here, right? No, these are two separate things. I mean, I could have drawn a Venn diagram for this too, you know. But I could use the Morgan's laws as well. All right. State with reasons whether A and B are independent. If A and B are independent, the probability of A intersect B is going to be the probability of A multiplied by the probability of B. The probability of A intersect B is 3/20. Is it equal to the probability of A multiplied by the probability of B? Yes, it is. So 3/20 is equal to 3/20. Therefore, A and B are independent events. Cool. The following table shows the marks obtained by 27 students in a mathematics test. Construct a stem and leaf diagram to display this data. All right, so for the key 1 to 2 represents 12. Just give an example for the key, right? So I had the stem part and the leaf part. Stem, leaf. So let me go. 27 students. It looking like we starting with it. Is it already in order? Damn. It looks like it's in order already. So we have 3, then 4, then let me leave some space. 3, then 4, 5, I have 6s, 7s, 8s, and 9s. 5, 6, 7, 8, and 9. So it's in order already. So I have 0, 5, 9, 2, 5, 5, right? 2, 9, 1, 1, 5, 9, 0, 1, 5, 7, 9, 1, 3, 3, 5, 7, 9, 0, 0, 5, 8. State one advantage of using a stem and leaf diagram to display the data. So one advantage is the data is arranged in such a way that it's easy to see. We don't have no big set of data to put in our stem and leaf diagram. Stem and leaves, you could see the shape of the distribution, whether it's positively skewed or negatively skewed. What's the next advantage of using a stem and leaf? These types of questions I really don't like because an advantage of using a STEMALIF could be a disadvantage. So if I have something to compare it to, maybe that will make a little more sense to ask. For example, state one advantage of using a STEMALIF over raw data. It takes up less space. I could have 1,000 raw data scores and I could put it in a STEMALIF diagram that comprises of 10 lines. All right, so those are just some of the advantages. And I wouldn't write down all. State the range of values of the marks obtained by the students. 98 take away 30. 68. 98 take away 30, which is equal to 68. State two distinct observations about the data seen in the box and whisker. It's negatively skewed. We can see it's negatively skewed. We can also see, all right, so look at the 30 to 71, right? That will represent 50% of the scores. Then 71 to 98 will represent the next 50% of the scores. Now, when you hear the word 50%, you just expect to see the box and whisker to be equal. First 50%, that distance to be equal to the next distance. But what that says is 50% of the students score between 30 and 71. The next 50% of the students score between 71 and 98. So don't look at that distance between 30 and 71 and the distance between 71 and 98 and think that, oh, okay, the percentage of students between 30 and 71 is more than the percentage of students between 71 and 98. 71 will be my median, which means my 50th, my middle mark. So 50% of the students will be before that, 50% of the students will be after that. So because 50% of the students scored between 30 and 71, we can say that the values are more dispersed, they are more spread out in the first half of the data. You could also say that the values are more compact in the second half of the data. Right, so those are just a couple observations you can write regarding the box and whisker plots. That's it for number 6. That's it for 2022. Next week, 2021.